Most valued student, my name is Confident. Welcome to our 24-minute lesson. In this lesson, we're going to look at the section of trigonometric identities, and the section we're going to look at is the proof of trig identities. Now, these questions are taken from the previous papers, and I'm going to give you strategies on how you can approach trigonometric identities when you are given such a question in an exam. Now, let us start by looking at the first question that is given. In the first question that is given, you are supposed to, it says use trigonometric identities to prove that cos 360 minus a is equivalent or is identical to the right hand side. Now, whenever you are proving, you have to choose either you are choosing the left hand side or you are choosing the right hand side. But in this case, you can see that I have more things on the right hand side, so I'm going to choose the right hand side. So if I start with my right hand side, I have to indicate that I'm starting or I am focusing on the right hand side. So now what we are given on the right hand side is 1 minus sine squared 180 degrees plus a all over 1 minus cos 180 degrees plus a. So now we are starting, as we said, with the right hand side, and now from the right hand side we want to prove that it becomes our left hand side. So now what are we given? You can now, if I can divide my page, I'm going to do my working. Instead, I'm going to do my working on the right hand side of the page. So now what I'm given is, if I can look at sine squared 180 plus a, now I can use now my cast rule. Now my cast rule, remember, it says all students take chemistry. Now I will encourage you to go through my previous lessons where I'm teaching this lesson. Now if it says all students take chemistry, it is giving you the quadrants where all means all cos, sine and tan are positive, and then S means only sine is positive or sin is positive in this quadrant, which is quadrant number 2. If I can use another pen, this is quadrant number 1, this is my quadrant number 2, this is my quadrant number 3, and this is my quadrant number 4. So it means in quadrant number 2 only sin is positive, in quadrant number 3 only tan is positive, and in quadrant number 4 only cos is positive. Now in my first part, I'm given sin squared 100 into 180 plus a, but this can be written also as sin 180 plus a, and then I have got a bigger bracket, and that's where you put this squared. So this is the same in writing. So now if I'm looking at 180 plus a, this is my third quadrant. In the third quadrant, that's where I find 180 plus theta. So in this case, you can see that only 10 is positive, which means sine or sin is negative. Then this becomes minus sin a squared. Now if you've got minus sin a squared, this is same as minus sin a times minus sin a, and then that becomes now positive sin squared a. So now you can see that we have reduced, in this case, we have reduced sin squared a, it reduces into that sin squared a. I mean sin squared 180 plus a, it reduces into sin squared a. So this is how you use the reduction rule to reduce that. Again, I can use the same way to reduce cos 180 plus a. So if I can get a bit of space to reduce that, if I use a different marker, I've got cos 180 plus a, and I have to reduce that. Now if you can see again, we said it is in the third quadrant, and then in the third quadrant cos is also negative, so this becomes simple negative cos A. So again, I have reduced that. So now if I can now pull it back to my original, so that I can have, in a way, the reduced way, I have got 1 minus, now where there was sine squared 180 plus A, I'm going to write the reduced version, which is, in this case, we said it was actually sine squared A, so I've got 1 minus sine squared A over 1 minus, and then in bracket, remember we got negative cos A. So this is the reduced version. Now we can see it's a fraction, which is 1 minus sine squared A over, now there are two negatives at the bottom, a negative and a negative becomes a positive, which is, in this case, it will be 1 plus cos A. Now there are different ways now you can approach in order for you to solve this, but suppose in the first one I choose to solve it as a fraction. Now when I choose to solve it as a fraction, I can say this is 1 over 1 minus sine squared A over 1 plus cos A, and in this case you can see that the common denominator is 1 plus cos A. So this is, you need to know this, how to solve fractions. In the first one, 1 into that, it's 1 plus cos A times 1, which is 1 plus cos A. Now minus 1 plus cos A into 1 plus cos A, it goes once, and then minus 1 times sine squared A. So as I said, you need to know how to solve your fractions. Now if I've done that, just to get a bit of space, I can then move on to say this is the same. If I rearrange this, this will be the same as 1 minus sine squared A plus cos A. This is just a matter of rearranging. I'll show you the reason why I did that, over 1 plus cos A. And you will see why I did that particular rearrangement. Now, when I have done that, there is something interesting with this rearrangement, and the reason why I did that is to use my trig identity, which says cos squared theta plus sine squared theta. You remember this identity says is equal to 1, but if I rewrite it, I can say cos squared theta, and then I take sine to the other side of the equation, it will become 1 minus sine squared theta. Now you can see that I have got 1 minus sine squared theta, and I've got 1 minus sine squared theta, which means instead of this 1 minus sine squared theta, I can now actually equate it to cos squared theta. So in this case, instead of 1 minus sine squared theta, I can actually here have my cos squared theta. So in this, that's the reason why I was referring to say there is a reason why I'm rearranging. I was rearranging because already I was trying to achieve that. So in this case, I'm having now my cos squared theta, or my cos squared A in this case, plus my cos A all over 1 plus cos A. Now you can see this, then if I can simplify it, this goes over. You can see that I can factorize on top. I can take out cos A, which is common, which I will have cos A plus 1 all over 1 plus cos A. Now with this, then I can be able to cancel cos A plus 1 as 1 plus cos A, because this is the same, and this can then give me cos A. Now if I look at the question, go back to the previous question. The previous question was saying prove that cos 360 minus A is equal to that. But now if I can come here and the answer, you can see that I got cos A, not 360 minus A. But now you can then move on to say, in this case, I have got my left hand side. Now my left hand side, now in my left hand side, I have got cos 360 minus A. Now if I use also the quadrant, this is in the third quadrant. If I take you back in that quadrant part, you can see now this 360 minus A cos, it is in the third quadrant and cos is already positive. So now if I use the reduction rules for that on my question here, cos 360 minus A, if I use the reduction rules and cos is positive, this is same as cos A. So now you can see that if I reduce my left hand side, I get cos A. If I reduce my right hand side, I also got the previous one, which was cos A. Now then you can conclude that therefore the left hand side is equal to the right hand side. So in this case, you have managed to prove. So this was one way you could have approached this particular question. But also there's something interesting. If I can take it from here, maybe use a different marker. If I can come here, I'm not going to solve the whole of it, but I just want to show you how you could have gone about. If I can take this part here and rewrite it here and say 1 minus sine squared A over 1 plus cos A. See, I can look at this and say, using my identities again, remember the identity that I wrote, if I can use this particular identity here, you can see that if I want to remain with sine squared, so in this case I'm going to have cos squared theta plus sine squared theta is equal to 1. But now I want to remain with sine squared, so I'll have sine squared theta is equal to 1 minus cos squared theta. Why am I remaining with sine squared? Because now sine squared is the one that is represented on top. So now I can rewrite this in a way and say this is the same as 1 minus, and then I write 1 minus cos squared theta over 1 plus cos theta. And if I continue working this will become a difference of 2 squares, which is 1 minus cos theta and 1 plus cos theta. As I said, you need to go back to my previous lessons so that you can see that this is a difference of 2 squares. So if I continue, this will be 1 minus, and I've got 1 minus my cos theta and 1 plus cos theta all over 1 plus cos theta. Now you can see then that this can then cancel that, and then at the end of the day you are going to be having 1 minus cos theta. Then when you open up this bracket, the negative will distribute itself to the 2, which will be 1 minus 1 plus cos theta, because a negative and a negative is a positive. Now 1 minus 1 becomes a 0, then this symbol becomes cos theta. So now, as I was saying, if this becomes cos theta, then you are back to the previous one, whereby you got the first one as equivalent to cos theta. In this case, you can see that this simplifies to cos theta. It also simplified to cos theta, but we went on to prove that cos 360 minus A was equivalent to cos theta. So this is how I meant when I say you can look at the left hand side And then if you see that it's not simplifying to the right hand side, go and look at the final right hand side and see if ever it can be also further simplified, and you will discover that your left hand side then is equal to your right hand side. So this is one approach that you could have done. Let us look at another example, which is 4 marks. It says you are supposed to use trigonometric identities to prove that the left hand side, which is this part, is equal to the right hand side, which is that. So now we can see that my left hand side is one which has got more stuff or more things, so I can choose my left hand side in this case. So I can start with my left hand side. So now in my left hand side, what am I having? I've got 1 minus sine theta minus cos theta squared all over sine theta. Now when I do that, I can move on to say there is a bracket with a square, so I need to simplify that one. So if I can choose a different pen, so what I'm having here, I've got sine theta minus cos theta. Now because it's a square, it means these are two brackets, which is sine theta minus cos theta. The square means that there are two that are similar. So now I can expand that. If I expand that, this will sine theta will multiply sine theta, and cos theta will multiply cos theta. And also on the other side, cos theta will multiply, remember the distribution, cos theta will multiply sine theta, and cos theta will multiply cos theta. So if I do that, the first one I will have sin squared theta, and then I will have minus sin theta cos theta, and then after that I will have also minus cos theta sin theta, which is same as, you can write it to match the first one, minus sin theta and cos theta plus the last one is cos squared theta. This is simple expansion, and then when you have done that, what I have now is sin squared theta. I'm going to bring this closer, which is plus cos squared theta. I don't know that you see the reason why I'm bringing those close, because that is an identity, minus, now you can see that these are the same, so it's minus 2 sin theta cos theta. Now if I move on with this, I can then conclude a few things here. Now if I take this one, sin squared theta plus cos squared theta, you know that is an identity, and that is equal to 1. So I've got 1 minus 2 sin theta cos theta. So that's what I'm having. So now if I can take that all together, then I'll be having equal to, I'm continuing in this case, I'm continuing now my question. I'll have 1 minus, where there was this bracket with a square, now I'm going to write that part, which is 1 in brackets now, 1 minus 2 sin theta cos theta all over sin theta or sine theta, which is equal to, now I have to distribute this negative. In this case, this negative will be distributed to 1, so it's a negative 1, and the negative will become a positive. So now I'm going to have 1 minus 1 plus 2 sin theta cos theta, and then this is divided by sin theta. Then I'm going to have, this will cancel out. I'm going to have 2 sin theta cos theta all over sin theta. In this case, I'm going then to cancel out, and I'm cancelling out the sine, and then I'm going to have my final answer is 2 cos theta. Now you can see that then this becomes my right hand side. So in this case, I've managed to prove that the left hand side is equal to the right hand side. Now we have come to the end of our 24-minute lesson, and I will encourage you again to go through these problems or through the examples that were given so that you can get more practice. And trust me, it will be easier when you face these similar questions in the exam. Thank you.